Okay, so this video is about how to construct the Fourier series of a function which is periodic. Let's say f is periodic, and the period is capital T. Then its Fourier series will have the following shape. We use the following notation with Fourier series of f, which is a function of x, will be a naught over 2 plus a sum from 1 to infinity a n cosine 2n pi x over t plus bn sine 2n pi x over t. Now, a naught, an, and bn are Fourier coefficients. These are the main things that we need to obtain Fourier coefficients. Now, how to obtain them? A naught will be an integral 2 over the period t. Integral, here actually what is important is just we have to integrate on an interval of length t, which is the period. But for simplification, we use minus t over 2, t over 2, f of x dx. An 2 over t, the integral between minus t over 2, t over 2, fx times cosine 2n pi x over t dx. And bn will be about the same, 2 over t, integral between minus t over 2 and t over 2 fx now times sine 2n pi x over t dx. Now, before seeing an example, there are some properties that are very important to know that can simplify some calculations. Now, first one is about odd. F is odd. This means f of minus x is minus f of x. Example of odd functions would be sine x, could be x cubed, and x at the power of any odd number, okay, x cubed and so on. Now, the graphs will have the origin will be a central symmetry for the graph of an odd function. That means if I have to show that a given function is odd, I may need to find f minus x and show that it's the same as minus f x, or plot the graph on and show that there is a central symmetry at the origin. And the result of this is that if you integrate between minus t over 2 and t over 2, a function that is odd, the surface area will be the same. One will be positive and negative. One doing the sum, it will be 0. Okay, that's the main homework here for odd functions. Now, for an even function, f of minus x will be the same as f of x. Examples of even functions: cosine x, x squared, x4, and so on. Now, it will happen for an even function, the y-axis will be a symmetry. Now, the result is if you integrate between minus t over 2 and t over 2 f of x dx, it will be the same surface area before 0 and after 0. So we just need to integrate between 0 and t over 2 and then multiply it with 2, f of x dx. The last remark is about the product. So if I have product of functions, so let's say this is an even, here I have odd, even, and we have odd. What will happen if I multiply two functions, both of them even, then the result will be an even function. Even times odd will be an odd function. We can think about it as having -1 times 1. And here, if we have even, odd, it's the same, that will be odd. The last one, odd times odd, will be an even function. Because when we are dealing with the coefficients, we'll be dealing with f of x times cosine and f of x times sine. Now, let's see an example. If f of x is 1 between -2 and -1, it is x between -1 and 1, and it is -1 between 1 and 2. And the period capital T is 4. So the first thing to do is to sketch the graph of this function. It's on one period. So let's say this is 2, we have 1, -1, and -2. Now, between -1 and 1, f of x is just x. Between 1 and 2, f of x is -1. And between -2 and -1, f of x is 1. Now what you can notice here is there is a symmetry at 0. What is here is reflected to this point, and this line is reflected to the other part. So we have 0 as central symmetry. Which means f is odd. Okay, between -2 and 2. Now we have to find the coefficients. The first one, a naught, the formula is 2 over t. T here is 4. We integrate between -2 and 2 f of x dx. But this is 0 since f is odd. For an, we have 2 over 4 integral between -2 and 2 f of x cosine should be 2n pi x over 4 should be n pi x over 2 dx. Now f is odd, cosine is even, so the product will be an odd function. That's why this integral will be 0 as well. Finally, we have to find Bn, which is 2 over 4, that means 1 over 2, integral between -2 and 2 f of x sine n pi x over 2 dx. This time sine is an odd function, f is an odd function, so the product will be an even function. That means instead of integrating between -2 and 2, I could just integrate between 0 and 2 and multiply the result with 2. But since we have here 1 over 2, at the end we have integral between 0 and 2 f of x sine n pi x over 2 dx. Now f of x has different values. Between 0 and 1 it is x, so between 0 and 1 it is x times sine n pi x over 2 dx, and between 1 and 2 f of x is -1, so it will be minus sine n pi x over 2. Now how to integrate this part just by parts, or we use the tabular form. Just to remind, we have the polynomial here x that we need to differentiate until we obtain 0. And for sine n pi x over 2, we need to integrate. The first time will be minus 1 over n pi over 2, that means 2 over n pi. Cosine n pi x over 2. We integrate again, that will be minus 4 over n pi squared times sine n pi x over 2. And we have to do these products starting with plus followed by minus. So finally Bn will be minus 2x over n pi cosine n pi x over 2 plus 4 over n pi squared sine n pi x over 2. This is between 0 and 1. And for negative sign, if we integrate, that will be cosine. So plus 2 over n pi cosine n pi x over 2 between 1 and 2. So we place x with 1 minus 2 over n pi cosine n pi over 2 plus 4 over n pi squared sine n pi over 2 minus, when x is 0, obtain 0, and here as well, since we have sine 0, 0, plus here when x is 2, that will be 2 over n pi cosine n pi, minus when x is 1, we have 2 over n pi cosine n pi over 2. The first and the last are the same, so Bn will be minus 4 over n pi cosine n pi over 2 plus 4 over n pi squared sine n pi over 2, and then plus 2 over n pi cosine n pi. Now, these are the coefficients. If we had to find the Fourier series, then we just need to replace a0, an, and bn with their different expressions, and that will give the Fourier series of the given function. Now, we just need to notice that a function may be neither odd nor even. That means, in that case, we may not have the simplification of getting 0 for some of the coefficients.